All right, gang, more on hypothesis testing. The purpose of this video is to transition you from hypothesis testing for proportions to hypothesis testing for mean. Uh, Good news is the same principles apply. Everything we learned from hypothesis testing for proportions works, except for a couple of caveats. The bad news is when the population standard deviation is not known, which is typically the case, then we don't use the Z distribution as we learned with hypothesis testing for proportions. We use the T distributions. And I don't really think this is real bad news because with technology, the T distribution is just as easy to navigate and manipulate, if you will, as the Z distribution. So what I'm going to do is I'm going to take you through three examples. Well, I'm going to take you through one example three different ways. We're going to see how the critical value approach works. Then we're going to look at the p-value approach. And then I'm going to look at the how we would work this with technology, which is typically the way you're going to work problems. So let's say that we're going to use the critical value approach to test that the mean is equal to 20 versus the mean is not equal to 20. Well, just like in proportions, the second step is to state your alpha and evaluate your sample data. Well, our alpha will soon to be 0.05. Our sample mean, let's say it's 23.1. Sample standard deviation, 4.2. And let's say our sample size is 40. All right, need to tattoo this into the brain. For us to be able to work these problems, our sample size must be 30 or higher, or we have a normal distribution. So if I have a sample size of 5, I must have a normal distribution, or this process doesn't work. The normal distribution doesn't model the phenomena. If I have a normal distribution, it doesn't matter what the sample size is, 2, 5, 1,000, whatever. We meet that criteria. But again, sample size less than 30, I must have a normal distribution. So once the dust settles on this part, we define our critical region. So let me show you what that is. Now remember, when our alternative hypothesis is not equal to, we have a two-tailed test. So we have to have two tails of rejection. So because I am working with an alpha 0.05, then I need 0.025 in this region and 0.025 in this region, working with a T distribution with degrees of freedom 39. So again, easy to do. Just go to the T distribution. I need my degrees of freedom to be 39, and I need my upper tail to be 0.025. And I can see that I get 2.023, which, I've written right here. Now, daggone it, I wish it didn't reset with my hand. My old document camera didn't do that. This one is just annoying me to no end. Now, because of symmetry, if I have 2.023, I know that to have area 0.025 to the left of some value, again, in the T distribution, mean 0, because of symmetry, this has to be 0.2023. But what if you forget that? If you get on a test and that just completely blows your mind and you forget it, well, if I put 0.025 there and compute, you see I'm just going to get the negative of the 2.023. So regardless how you get it, whether you calculate it using StatCrunch or you use the fact that we have symmetry, so whatever this value is, the negative has to go there. Either way is fine. Next thing we do is calculate the test statistic. Well, it is the sample data minus the mu, so our point estimate minus the claim in the null hypothesis over the standard error. So in this problem, the mean is 23.1, our claim is 20, our standard deviation is 4.2, our sample size is 40, so divided by the square root of 40. When I put that in my calculator, I get 4.67. And actually, I still have that in my calculator, so I'll share it. I am always overly cautious when calculating test statistics to use parentheses because I don't want to take the chance of getting an incorrect answer. For example, let me just show you what happens. And I've seen this happen so many times. Let's say somebody gets sloppy and just decides that they don't want to use parentheses. And, you know, to someone still learning mathematics, that may look equivalent to what I did in the previous entry. Well, if you wake up tomorrow and you just want to get all your answers wrong, then do this because it's not going to work. You're going to get an order of operations issue. You're going to get the wrong test statistic. You're going to get the wrong p-value. You're going to get the wrong answer. You're going to say, well, I never could do math. Again, I see it happen over and over and over. Just don't do it. Use your parentheses appropriately to distinguish the value that you want to calculate in the denominator with what you want to calculate in the numerator. All right, gang, got our test statistic. Let's see where it lies. Well, it's clearly up here above 2.023. So this is my reject region. So my decision is to reject H sub O. Now, let's shift gears. The p-value approach. Well, nothing changes for the first and second steps. 1 and 2 still remain the same. We still report the null and alternative hypotheses. We state our alpha, sample data evaluated, so on and so forth. But the next thing we do here in the p-value approach is we calculate the test statistic. Well, I've already done that, so I don't want to be redundant and go through that calculation again. Now, here's the major difference in the critical value approach and the p-value approach. In the critical value approach, we divide our region with critical values. In our p-value approach, we divide our area by the test statistic. And since we're conducting a two-tailed test, we have to have the area above 4.67 and the area below negative 4.67. Now, again, easy to do. So I want above 4.67. And you'll see I get a very, very, very small answer. Well, that area also goes there, or the shortcut is just take that area and multiply by 2, which I did. And this is clearly below 0.05. So we get an answer that leads us to reject the null. Now, if I'm going to do, I mean, I think I think liberally educated people should know more than just how to punch buttons on technology. So that's why we go through these steps. But if I were going to carry this out, I would go to T-stats. Now, why do I know it's T-stat? Because I'm testing a mean and the population standard deviation isn't known. The population standard deviation was known, I'd do this, right? So one sample with summary. So the sample mean, let me grab this info, 23.1. The sample standard deviation is 4.2. And my sample size is 40. I am testing the mean to be 20 versus a mean not equal to 20. And I want to show my critical value for a significance level of 0.05. Now, when I get my output, you're going to see a lot of similar stuff. First of all, for the critical value approach, the 2.023 is found under the T critical. The test statistic 4.67 is found under the T stat. My degrees of freedom of 39, which I needed to calculate the critical value and the p-value. My standard error 0.6604, so on. If I were to take 4.2 divided by the square root of 40, let me just do that. It's not going to take, but just illustrate it. uh, I'm going to get 0.66407, which is reported there. Notice my p-value is very, very, very small, as we got on the last page. So if we get that right there. When it gets down that small, we have statistical significance at what we call the 0.001 level. So yeah, that's strong evidence against the null hypothesis. All right, gang, all I got. I hope I've impressed upon you that transitioning, if we have a firm base in hypothesis testing for proportions, that transitioning to means is a pretty simple move. All right, take care.